Hi everyone, Mr. Eric Kwa here, founder of Mr. Khemistry. Hope you're enjoying the videos that I've made for you specially. Remember to tap that like button and to click subscribe and to share with your friends if you found any of these videos useful or interesting. I look forward to seeing you around. Let's get started with today's topic. Alright guys, let's look at this question that talks about paper chromatography. So we have the colors, right, in a soft drinks analyzed by two different solvents. One is water and one is ethanol. So we have two samples, right, for us to take a look. So let's take a look at this sample on the left, right, where you can see the starting point of the solvent, right, is marked as X. Okay, the starting point is marked here as X. And then when you put a solvent, right, water here, water at the bottom, right, you can see that the dye, right, that correspond to orange moved up. For simplicity's sake, I would say it moved up 2 units, easier to count. Means that it moved up a lot, okay, when the solvent is water. Whereas for the black, it moved up half of what orange moved up. Okay, so this is what is shown by the left chromatogram. The right chromatogram, right, you see that if we use ethanol, right, the orange dye hardly moves. Whereas the black dye moves up about 1 unit. Okay, so bearing this in mind, right, they have given us a sample that this mixture, right, was subjected to two solvents. So the first one was water, right, first developed in water and then turn 90 degrees anti-clockwise. Anti-clockwise is obviously this way. And then the HPQ was placed in ethanol. So this is the second solvent. So if we look at the we take a blank, let's say we erase this, right, and we basically just start off at the point mark X, right. Let's think about it this way. Let's put it in water. Maybe we unrotate it. We put it in water, right? And then we try to put this solvent here along this axis. So what will happen to the two dyes? Okay, so if you put maybe your water, right? Let's take a look. In water, right, orange will move 2 units up. Okay, so the orange will move maybe somewhere here, right? And then after that, we see that the black move half of the length, approximately. Okay, so then after that, we put this ethanol in. And what will happen to the dye? So we look at the chromatogram on the right. The orange dye will hardly move. Okay, so we will lock in the position of the orange dye to be somewhere here. Okay, whereas the black dye will move up 1 unit. So maybe it will end up somewhere here. Okay, so we lock in the position of the black dye somewhere here. So orange dye will be here and the black dye will be somewhere here. Okay, this is in relation to the starting point that is marked X. Okay, so the only chromatogram, right, that is remotely near to this kind of placement is your option B. Okay, so if I erased off the option that is A, you realize that the two placement doesn't make sense. Okay, the two placement doesn't make sense. It's very far from where you will expect. Okay, so option 2 makes sense for the black and also for the orange. Okay, let's take a look at the other two. Also doesn't make sense. Orange is not supposed to be so far up. Okay, neither is it supposed to be so near to the origin. Okay, the origin where the mixture was first dotted in. Okay, so these 2 points are wrong. Okay, so that's why our answer is B. Alright, so rather than looking at the answer and trying to guess it, maybe it's better to put a blank chromatogram and just do the rotation yourself and roughly know where the dyes are supposed to end up. Alright guys, I hope this helps.